Okay, so we have another lightning talk, this time with Raisa Cuevas. She's going to cover augmented reality, which is really cool. So don't miss it, okay? Applause.
Thanks, Gerard. My name is Raisa. You might have seen my interview on Medium with the very own Gerard Sanz. I'm a creative engineer at Google, and recently my team was looking into ways that we can use augmented reality in one of our marketing campaigns that we wanted to build. So I took the liberty of doing my own research and seeing what's possible for the team, and naturally I started digging really deep and nerding out into the interesting history behind it with a really deep Google search. And I'm going to share with you today some of the interesting history that I've learned so that you can learn to appreciate what it is today and where it's headed in the future. So let's start with 1901. In this day, there were no airplanes yet, no color photography, and this was nearly a decade before the first motion picture with sound. Yet, before all of this technology and advancements, an author called L. Frank Baum, who you see in this picture here, he came up with this visionary idea that was pretty much a precursor to augmented reality. In a book called The Master Key, he wrote about an idea where there was a technology called there were these spectacles that was a character marker, basically. When you put it on and looked at somebody, it would overlay a character on top of their head that would allow you to judge them on a single look. So these were some pretty deep thoughts in 1901. And fast forward to 1968, when augmented reality was first made possible technically. This was a device invented by Ivan Sutherland, a Harvard professor. And as you can see from the clear lens, it had a translucent property that allowed you to overlay. It was actually a really simple image, just a wire cube that you could see in front of you. And for that simple application, this machine was so massive that it had to be suspended from the ceiling. So obviously something like this wouldn't make it into the consumer market like what we have on our phones or on our modern head-mounted displays, but it was a really important milestone in technology. And now looking at today, 50 years after the first head-mounted display, we have really compact ones like the HoloLens, a bunch of other devices out there, including your very own cell phones that you have in your pockets. And today, you hear about augmented reality all the time. Technologists and investors are talking about when it's going to be the next big thing for the past few years. So let's actually look at some of the more recent history. This is a graph of the search interest in the term augmented reality from the past since 2015. And if you look at these recent spikes, it looks like people have only been recently aware of or interested in augmented reality. So what has happened at these times of the spikes? First one, obviously, Pokemon Go. People are wondering, like, what is this cool new thing where you can overlay something and catch Pokemon? Everyone started talking about augmented reality for the time when it was popular, and then it started to dip down a little bit, but still gained a lot of interest. And more recently, we have the developer toolkits called AR Core and AR Kit that allow developers to build these augmented reality experiences a lot more easily. So let's first quickly define what these two tools are. AR Core is the platform for building AR apps on Android, and AR Kit is the platform for building those same kind of apps on iOS. Stepping back further, since the beginning of time that Google Trends allows you to search in 2004, you see that actually augmented reality isn't new. And as we've learned in history, it's been around as a concept for a long time. But somehow in 2009, people are starting to talk about it in a large volume. So what happened here? We had AR Toolkit, which made AR applications available for the web. And a lot of this was Flash-based, so there was still kind of a barrier to entry. People were building all kinds of cool games and applications, but it wasn't widely adopted, obviously. Another interesting thing that came out of this later in 2009 is that augmented reality was brought to the real world outside of the computer. And Esquire posted this, they sold this issue where there was a QR code on the front, and when you scanned it, basically, Robert Downey Jr. comes out of the page and gives you all this cool interactive content. But this was built with C++, and I think eventually became an app in Flash. So obviously, it didn't gain wide traction as it would have on a modern web application with native support. So looking at today, through the years of Google Hangouts, face filters, Snapchat lenses, HoloLens, Pokemon Go, and the well-known IKEA app, what makes AR possible today is that devices are more powerful, browsers are more powerful, and you have these augmented reality-enabled tools in your pockets, mostly. Developers are more well-equipped with AR Core and AR Kit, and the future support on the web is going to bring it to the masses. So let's get back to the basics and kind of define what these mean in technical terms. AR Core, in essence, is a software development kit that allows developers to use essential AR features in Android applications. So what these AR features are, it enables motion tracking, so the device understands and tracks the position relative to the world. When the camera moves, the scarecrow that you've positioned stays in place. Also, environmental understanding, so that the device can detect the size and location of the surface, and as you can see from the grid that overlays on the table, it knows where to place the item to make it look real. And then light estimation, so if there are changes in lighting condition, then it will react to that environment as you please. So since 2014, Google has been working on AR in a more specialized medium with these Tango devices, which had really advanced sensors and really high-performing cameras. But unfortunately, this was limited to a limited amount of devices. So recently, we've focused more on AR Core, which will allow this technology to be possible on Android phones. So the challenge here, but also the opportunity, is that Android is the biggest mobile platform in the world, with over 2 billion active devices. And in order to ensure the same quality across these devices, we have to make sure that the software is calibrated for different cameras, hardware specs. And currently, we've calibrated them for some of the most powerful devices, like the Pixel, Pixel 2, some of the Galaxy models. And although we're in developer preview now, we want to support 100 million phones at launch. So ARKit, it actually allows for the same essential AR features. Those AR features are just general to augmented reality as a whole, not necessarily just for AR Core. So light estimation, motion tracking, and surface detection in iOS 11 and up. One advantage they have here is that they have control of the hardware. So once ARKit was launched, it was quickly made available to the eligible iPhone and iPad devices that Apple has control over. But as front-end developers, most of you guys care about building for web. Who cares about native apps? It's boring. Luckily, there is AR Core for Web, which is an implementation of AR Core that makes AR possible in browsers. So recently, Google launched a blog post about how they're exploring this concept, and you can install some experimental browsers that make it possible, as they're demonstrating here in this image. And they're also thinking about, it's important to think about fallbacks for when someone is browsing an AR experience on their website or a non-AR compatible phone. So in the background here, you can see that there's a gray background. Then when you open up the AR experience, it'll overlay onto the camera. So AR Core for Web isn't a single entity. It's basically you're building a web app with certain JS libraries that allow you to create 3D models. And when you load them on these experimental browsers, such as WebAR on AR Core, or the version for Apple that is WebAR on ARKit, these are basically extensions of Chromium and WebKit that allow you to expose some AR features by extending the WebVR specs. And with this, on the demos that you see on the WebAR on AR Core GitHub page, a lot of the demos are built using Three.js, which is a really common library already. So if you are interested in 3D or you're using this already, then it's going to be really easy to jump on board and start building AR applications. And it's been widely used since 2010. In this image, you can see some of Google's examples like Interland and some previous marketing experiences that we built before use Three.js. But technically, you could use your own library as long as it's creating 3D models. And this is not the only web implementation. WebAR on AR Core is just a pre-standards exploration to demonstrate what the standards might look like and to show developers what's possible so that they can start exploring it today. Some more web implementations include the Mozilla WebXR standards proposal, which is a lot of the ideas kind of aligned with WebAR on AR Core. And then there's another experimental browser called Argon, which also uses its own library for the 3D modeling. And then the most common one I found is the marker-based AR.js, where there's kind of like a really big QR code that you point your camera at, and then the AR object will basically pop up out of it. So there's a lot of different ways you can do this. And I think it's important that if you want to explore AR, the fundamentals of 3D modeling are all pretty much the same. So yeah, why should we care about WebAR if there are no standards and it's not yet readily available? Well, it's interesting because it's starting to get really big now, and if we start to learn the tools before they become released to the public, then we'll be ready equipped to make beautiful experiences. So for more inspiration, there are some links here. Some are specific to AR Core or AR Kit, but one of my favorites is g.co/AR experiments. And just a shout out that half of the experiments on this site were built by women. So back to Ivan Sutherland, the Harvard professor who created the first head-mounted display. He said that the screen is a window through which one sees a virtual world. And the challenge is to make that world look real, act real, sound real, and feel real. So I think with all the technological advancements since 1901, as you've seen, that we're almost there. So on behalf of Robert Downey Jr. and Ivan Sutherland, we are almost there. And just a boring disclaimer that I am speaking on behalf of myself and not on behalf of Google. So this is all as a result of my nerdy, fun research on augmented reality, and all of this knowledge is publicly available, bundled up into a nice 15-minute talk for you guys. Thank you.